All right, so hello everyone, welcome. My name is Mauricio. I am accompanied by...
Hi, I'm Crystal.
I'm Josh.
I'm Thomas.
And I'm Jan.
And we would like to present to you our senior design project, the automated pool treatment system. So our scope is pretty simple. It's to design a system in which will automatically test and balance pool chemicals.
All right, I'm going to talk about a little background on our project. And I'm going to talk about three things in particular: how water comes to balance, the chemicals we're using, and current products for clean pools. So it can become unbalanced in many ways. One big one is you. If you apply the shampoo, the deodorant, the sunscreen, all that washes off can affect the balance. And your pets. They could be unclean, they could have tick and flea treatment, that also affects it. In the sun, not only the temperature can affect it, but also the UV rays. And what they do is that they break down the chlorine in there, and that affects the ORP. Another one is rainwater. And if you don't know, rainwater is acidic. And so that directly affects our pH readings. And another one is debris, leaves, twigs, that stuff. And when they fall in the pool, then they organically break down, and that can affect the balance. Okay, so the chemicals using is one, pH up, which increases the pH. pH down decreases it. And extra blue, which affects the chlorine. And we're focusing on pH and ORP because pH and ORP are the two main factors when figuring out if your pool is balanced or not. Because the pH can be too low, too acidic, and that's unhealthy. If it's too high, then it's a strong base, still unhealthy. So you want to get between 7.4 and 7.6. It's tough to do, but you can do it. And then chlorine. So we were testing for ORP. And ORP is how effective the chlorine is. If there's not enough chlorine, then the bacteria can hurt you, can affect you, make you sick. If there's too much chlorine, then I think you all know what happens when there's too much chlorine. Your eye hurts, your skin feels weird, it's unhealthy for you. And so we chose to focus on those two because they were easy to implement, they weren't that expensive, and they were the biggest factors. And you might ask, why didn't we test for other factors like alkalinity and calcium hardness? Well, mainly because they were hard to implement, they were very expensive, somewhere north of $500,000 just for a sensor to tell you alkalinity, above our price range. And while they are important, they're not as important as the pH and ORP. And so with pH and ORP, it'll give you a very good analysis and see if it's balanced or not. And what other cool cleaning products are there? Well, there's these little bots that, they go around on the surface, clean up the floors of their pool. That's nice, it's clean debris, which will help, but it's not gonna be your pool balance. That's stuff that you gotta do. You gotta manually put in the chemicals, manually test it, weight, all that stuff. So our project is going to do that for you. It's going to say, hey, is it balanced or not? No? Then it's going to put some chemicals in that it deems fit, test it again. If it's good to go, then it's going to say, hey, go ahead and swim. If not, then it's going to test it again. And Mauricio is going to talk about the design implementation.
Cool. So yes, this is our automated pool treatment system design. It features 3 chemical containers, one for pH down, pH up, and chlorine. We also have these 2 sensors in which we'll test for pH and also ORP, and 3 ball valves in which we'll dispense the chemicals. So the design is simple. All we're doing is basically we're tapping into the pool's main water system. So if we take a look at this scenario right here, our pH sensor is noting that there's too much pH. There's not enough pH in the water, excuse me. So it's going to dispense pH up. In this case, there's a lot of pH in the water, so it's going to dispense pH down. In this case, our ORP sensor is alerting us that there's too much chlorine. There's not enough chlorine in the water, so it's going to dispense chlorine.
Right. So I was in charge of designing the back end and the application. We decided to go with Amazon Web Services, and the reason we went for that is it acts as a serverless backend, which would make the work easier on us. It has a free tier that lasts a year, and even though the free tier has some limitations, what it offered still exceeded what we needed. And it also has a widely supported SDK and thorough documentation. First, we use Amazon Web Services IoT platform, which supports SSL encryption and TLS. It supports up to 250,000 messages per month. Next, we use Dynamo database to store all the pull readings and the user configurations. And this supports up to 25 units of read and write. And it also has 25 gigabytes of data. And last, we use Lambda, which has 1 million requests per month. And how this works is we had our device publish the pull readings and the configuration to the IoT platform. Lambda will pick that up and process the data and then store it in a Dynamo database. And then also the application will be able to query the database to get the pull readings and the configuration. And this also was able to go vice versa from the database and the app to the device itself. And then this is just a graph of our OOP when we were testing it out. And the SDKs that we used were the embedded C library for the microcontroller and the Android SDK. Over to you, Kristen.
So I'm going to talk about our hardware that worked and didn't work. So originally we went with the Photon Wi-Fi microcontroller, and this was because the hardware fit all our needs, it met all our pin requirements, and it had a Wi-Fi module. But unfortunately, when we tried to connect it to AWS IoT, it wasn't easily done, and so we had to switch over to the Adafruit Feather Weiss microcontroller. And the reason we chose this microcontroller was it had all the same hardware as the Photon. It was just easily compatible with AWS IoT. And one issue we faced with this was trying to move over the firmware from the Photon to the Feather. Another thing the embedded system team ran into was our brass solenoid valves originally sounded like a great idea. There was no minimum pressure flow and they were durable. And we thought they were going to work great. But after testing them out, the flow didn't flow as like we expected to. It was just kind of dribbling out. So we switched over to electronic ball valves, which worked great. They had a great flow of water because of the big opening, and it also allowed us to implement dispensing granular if we decided to. And we also had great control over the amount that the ball valve opened. We could open it 25%, 50%, or 100%.
To store the chemicals, we used an automotive coolant reservoir, as we knew it would be durable against the harsh chemicals used. We hypothesized that mixing chambers would be beneficial, but we did not go with it due to budget constraints and complexity. Thus, the user will just have to pour chemicals into the appropriate reservoirs and mix it themselves, which should only take them less than 5 minutes. The housing for this project was an off-the-shelf storage container bought from Home Depot, primarily made of durable plastic. This allows 2 individuals to sit on it, and it blends into the environment. This container will house the complete system, including the chemical storage containers, which are mounted onto the container's rear wall.
So our budget. We were initially given a budget of $1,200, and after we spent all the money on research and development, our actual prototype, we came in $100 under budget. So the total cost of the parts and pieces, hardware, everything used for our final prototype came out to $635.50, with the bulk of the cost going towards our probes and our electronic ball valves. So, unfortunately, during finals week, our pH probe broke, but we took a video, and with the conditions of the pH being at 5.15, and the video will show the pH up dispensing.
I'm just going to, yeah. So here's dispensing pH up chemicals into the pool. Keep dispensing until it reaches that main pH level that it wants. So there's continuous water coming in through the main pipe.
And so what it's doing is it's checking every 5 seconds if the pH has gone up into the area that we consider good. And once it checks it, it'll keep dispensing. And I think it dispenses for around 10 seconds.
So then we'll go to
So that's that. And luckily, our ORP probe is still working. So we will do a live demo of that.
Pulls water pump. Okay. So what we did is we added red color dye into the chlorine. So you should be able to see it dispense into the pool. It needs to connect to the service. So.
Say again? Oh, yeah.
So maybe you can't hear, but our ball valve just opened.
It should turn red. Okay, so that's what happens when there's live demos. But yeah, that's the whole gist of it. It should dispense chlorine into the pool. So, our next slide. And we have a couple of things that we like to give out too. Let's go back to it. Which is like this. We'd like to thank Leslie's Pools Supply Company. We went over to them and did some research, and they gave us some really vital information. And also Home Depot. They helped us out, especially Jim, not Jim in our project, but that's Jim. And they also gave us nice student discounts throughout our project. So, yeah. But dispensing red.
Slowly but surely.
Slowly but surely. Yeah. And then that's pretty much about it.
Before the next team?
Terry.
Hey, so do you expect any issue with the electronics and the chlorine? Shouldn't there be some kind of interference? Electronics and chlorine don't usually go well together.
No. All we're doing is we're tapping this main system into the pool's already existing water system. There's already an electronic compartment already housed in the, if you take a look at your regular pool, there's already electronics like a cabinet or there.
But there's not concentrated chlorine.
Yes. We tested the ball valve and we made sure that we actually had some chlorine leak into the wiring. And as far as we know, nothing's happened so far, but that's the one thing we could look at in future scope. Any other questions?
Does it dispense different amounts of the chemical depending on what the pH level is, or does it just dispense a set amount?
Yeah, so when we're looking at the pH, for a 10,000 gallon pool, it's supposed to dispense about 12 ounces. So, and then so that's what it is.
And also,
For different amounts?
yeah, depending on where the pH level is at, there's certain amounts you have to dispense ounces wise. And so, yeah, and so there are calculations that we have that put the amount of gallons that are in the pool and what the levels are at. That would tell you what you need, how much you need to dispense.
And is there any chance for you to overshoot the pH and then have it start to dispense the pH down, for instance, and end up oscillating back and forth?
Well, in our demo, it's opening and closing very fast, but in reality, it will dispense and wait for a little time, for a half hour, an hour or so, and then it will test again, so that it wouldn't shoot too much and shoot too little without really knowing where it's at. So it's gonna take a little time to let it settle, and then it's gonna test it again. And then if it's too low, it'll dispense the equation amount, or make it lower if it's shot too high.
Great, thank you.
All right, good, thank you.